Now we're going to use our triangles to find the sine, cosine, and tangent values of some special angles. And some special angles that you're going to see over and over in this course are going to be 30 degrees, which is the same as pi over 6, 60 degrees, which is the same as pi over 3, and 45 degrees, which is the same as pi over 4. So we're going to use an equilateral triangle to help us with the 30 and the 60 degrees. So if we have this equilateral triangle and we're going to let it have sides of length 2 to help us out. An equilateral triangle has angles that are 60 degrees. Now if we cut that right in half, so we're just going to cut right here, right down the middle. Okay, so this is still going to be 2. This is still going to be 60 degrees. We're cutting it perpendicularly so that this makes a right angle. This is a 30-degree angle. Okay, now we've split this in half, so this is going to be 1. Now, to help us out, we need to find what this third side is, and we'll have to use the Pythagorean theorem. So here, 2 is our hypotenuse. So if we look at a squared plus b squared equals c squared, we're going to have 1 squared plus b squared equals 2 squared. So 1 plus b squared equals 4, which means b squared equals 3 if we subtract 1 from both sides, which makes b equal to the square root of 3. So this side is the square root of 3. So let's look at 30 degrees. We're going to let 30 degrees be our theta. So this side is always going to be the hypotenuse since it's across from the right angle. But with 30 degrees as the theta we're focusing on, that makes the 1 our opposite and square root of 3 our adjacent. So sine of 30 degrees would be opposite over hypotenuse, or 1 over 2. Cosine of 30 degrees would be adjacent over hypotenuse, or square root of 3 over 2. And tangent would be opposite over adjacent, which would be 1 over square root of 3. Now normally we don't like square roots in our denominator, so we do what's called rationalizing the denominator. We're going to multiply this by square root of 3 over square root of 3, which will give us square root of 3 over square root of 3 times square root of 3 is 3. So tangent of 30 we say is square root of 3 over 3. Okay, so we've now found, using this special triangle, sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees. Okay, now what if we look at the other angle? Let me change my pen color. Let's say we let our theta be our 60 degrees, okay? Well, the hypotenuse stays the hypotenuse, but now the one that it's kind of sitting on becomes our adjacent, and the one that it's across from becomes our opposite. So when we want sine of 60, we're going to take the opposite now, square root of 3, over the hypotenuse, 2. And when we want cosine, we're going to take the 1 over 2. And when we want tangent, we're going to take square root of 3 over 1, which is just square root of 3. Okay, so by using this equilateral triangle and starting with sides 2, we're able to find this. And if we used a bigger or smaller equilateral triangle, we would have just had to reduce our fractions. So this would actually work with any equilateral triangle, but 2 just kind of makes the numbers very, very easy. Now I said our other special angle was 45 degrees, so let's look at a square that's going to help us. Okay, so here we have this square, and we're going to have all of the sides be length 1. Now what happens, so these are all right angles. What if we cut that square from diagonal to diagonal? So I always say, think of this is how I like my grilled cheese sandwiches cut as a kid, kind of cut across the diagonal to make 2 triangles. Now, so the sides here are 1 and 1, and this is still a right angle, but this angle is now 45 degrees, and this one's 45 degrees. Now we do have to use the Pythagorean theorem to find the other side, the hypotenuse. So a squared plus b squared equals c squared. We're going to have 1 squared plus 1 squared equals c squared. 1 plus 1 equals c squared. So c will be the square root of 2. Okay, so now here it doesn't matter kind of which 45 degrees we think of as our theta, so we'll choose that one. Now no matter what, the square root of 2 would be our hypotenuse. Now with this one, this will be our adjacent and this will be our opposite. So sine of 45 degrees will be opposite over hypotenuse, or 1 over square root of 2, which to rationalize this we need to multiply by square root of 2 over square root of 2, which would give us square root of 2 over 2. Cosine is going to look very similar. We still have a 1 in the adjacent spot, so 1 over square root of 2, which when we rationalize it becomes square root of 2 over 2. And tangent, opposite over adjacent, would be 1 over 1, which is just 1. So sine of 45 degrees is square root of 2 over 2. Cosine of 45 degrees is square root of 2 over 2. And tangent of 45 degrees is 1. Okay, so these three angles and their trig values are things that you're going to see a lot throughout this course. And I just wanted to show you how we came up with those values.